In this video, I'll be dealing with two important semantic issues: linguistic codification and argument structure. These two concepts are related to each other. We'll be basically trying to study some examples of logical representation. The first important concept is linguistic codification, and it has to do with the way language captures a concept or an idea and how this concept or this idea is fixed into the system. This process, I said that before I think, this process is called codification, and it means that a thought needs a more material or physical side so that it can be communicated. We have seen examples of how a concept is differently codified in different languages, and I've already told you or asked you if all words mean in the same way. No, they don't mean in the same way, as we've seen. Words taken in isolation can be used to refer in basic situations, such as, for example, when you point to something like my keyboard or the mouse or the screen or my ear, and then I'm referring. But when I use the same word to capture classes of words, then I'm using that word to denote. For example, keyboards. In that case, I'll be using plural mark. But what has this to do with propositions? There are authors such as Hartford and Hirsley who define this concept of proposition as that part of the meaning of the utterance that a declarative sentence has when it describes some state of affairs. That's pretty complicated, but it's what they or how they define this. So let's assume that there's a level of abstraction in thinking at which everything we want to talk about can ultimately be conceived as an entity or as a relation. Let's revise what we think of entities and relation. Everything we can talk about in the world can be ultimately conceived as an entity or as a relation. And sometimes when you talk about something, you can put it into words in a way that it looks like an entity or it looks like a relation. We'll see a couple of examples later. In most languages, entities are identified with nouns or with names. Relations, on the other hand, are in most languages identified as verbs. And entities and relations, both of them are the stuff that predications are made of. Remember this chart that we seen previously in other videos that you've probably saw before. We can see that we can go from top to bottom or from bottom to top. If we start with utterances, then we start with the more concrete side of units in language, the ones that, as I said before, had this phonetic side. We can hear them and we can produce them. Sentences are what is left if we disregard the phonetic side of utterances and we concentrate on syntax. But they are still fairly abstract. But if we go up from utterances to sentences, then we shake out aspects such as those related to different types of sentences, speech, and we only focus on the number and type and syntactic roles of participants and on the kind of relation that's usually verbs that links them. So let's take the last example that we commented previously, and let's see the different sentences that we can produce out of one kind of argument structure that's made up of the relation break and the two entities, Matthew and glass. Or the other example where we have relation and then an entity war. Or another verb or another relation that is tell, and then three entities, Lucas, Lie, and Nicholas. And if we put these arguments and predicates together, we can produce, for example, three different types of sentences. We can produce a statement such as Lucas told Nicholas a lie, or a question, did Lucas tell Nicholas a lie, or a command, Lucas, tell Nicholas a lie. So these three sentences share the same propositional content, and this is important. There's one relation, that's tell in the previous example, and two entities, Nicholas and Lucas. There's three entities, Nicholas, Lucas, and lie, because lie has been considered as an entity. Lie is the opposite of truth, so here it's lexicalized as a noun, a word that is a noun. There's several ways of representing this. The first is a mathematical approach. Let me give you the example. The Winter gave me a bottle of an excellent 1996 Rioja, where the function is the generic form of referring to a function in mathematical terms, and then two entities, A and B. Which ones are these two entities? One's the Winter. Winter is someone who produces wine, and a bottle of an excellent 1996 Rioja. This long sentence can be conceptualized as just a bottle or a bottle of wine. And then, if instead of this we try to represent this in logical terms, we again have the predicate, that in this case is represented by a capital G, and the two components, the Winter and the bottle of an excellent wine. Why this is so? It's just a convention or a conventional representation. Conventional representation is important here because it has to do with different ways of representing the argument structure of a proposition in a more iconic way, and following some kind of agreement among the experts in this matter, which are linguists and logicians. Logicians have widely agreed on having a common system of representation of this logical relation. So it becomes a little bit more complex, but to sum up, entities are represented using their initial letter in low case, whereas predicates are represented with their initial letter but using uppercase letters. So revising the idea of argument structure, which of these two formulas equally represent the logical content of the following sentences? The following sentences that we've already talked about before. Peter told Nicholas a lie. Peter told Nicholas a lie. Did Peter tell Nicholas a lie? And then tell is represented by a capital T, and the components or the arguments of this structure are Peter, Nicholas, and lie. Here I didn't forget to write the lie, because it's an important entity in the whole thing. So the argument structure relates a relation or function with a number of arguments. In a proposition, logicians identify verbs as relations, and in a proposition these verbs functions with subjects and as arguments in that same function. The best thing to do is just to go back to this little formula here, where we can very clearly see that T is the representation, the abstract representation of the predicate tell. P is Peter, a human being called Peter. N stands for another entity, it's a human being called Nicholas, and L stands for another entity, in this case an abstract entity, which is the concept of telling someone something that's not true. And even if it's an abstract concept, in logician terms, it is still represented with the same system, with lowercase initials.